I have with me a lineman, Mike Birkenpass, is a lineman for Northwest REC. Mike, how long have you been a lineman?
19 years.
So he's been a lineman for Northwest REC for 19 years. So a lot of time working on the line. You've seen a lot of times where feed trucks, grain bins, and things like that have made contact with the line, haven't you?
Correct.
So, so what we want to do is try and give everybody an idea of the power of electricity. And that's what this demonstration is about. So we'll go ahead and begin, and the tools that Mike has with him, that we both have. He's got a hard hat, safety glasses. He's got rubber gloves. These rubber gloves are tested and put back out of service and then back in service every 30 days. So we have a lot of equipment that we spend a lot of time making sure that is in good shape. The tool that he's holding in his hand there is called a hot stick. Trade name is a shotgun because it's got the slide on it. It seems like a pump shotgun. That is tested for 100,000 volts for every foot. And we test those regularly as well to make sure that they're always in good shape. He visually inspects all of his tools before we work to make sure that they're prepared for the job that we do. Nobody has tools that do this other than utilities, so don't take a piece of PVC pipe and think you can use that to protect yourself from electricity. Another thing, a lot of people think wood is an insulator, and wood's not an insulator. Wood has moisture in it and can conduct electricity quite well. We'll demonstrate that with a tree branch as well. But the first thing we're going to start off with is the hazards of touching a power line. What we're doing is backfeeding a transformer with a generator. So this would be an example of an improper installation of a generator. If we follow from the generator, we're coming with 240 volts through that cord. If you follow it along, we're connecting to the service wires coming in to the house or to the farm. So normally the transformer feeds the farm, feeds the business, feeds the home. In this case, we have improperly connected a generator, so it's actually backfeeding the transformer. Transformers don't care which way they get served. Normally they take high voltage and step it down to distribution voltage for the home or a usable voltage for the home. In this case, we've improperly connected the generator. We're backfeeding the transformer.
And you're feeding the line to the back. So if you improperly connect the generator and storm to look out,
this could potentially backfeed and working on the line. So that's why it's important to understand to properly connect your generator with an approved disconnect and a standby generator switch in order to do that. So when we energize this light is connected, this light bulb is connected to the secondaries of the transformer, but not to where the normal power would be. So this is proof that the transformer is energized on the secondary side. When we energize this, that light will come on to indicate that we do have power. But you won't hear anything. The buzz you can hear right now maybe is the generator outside. But if you had a solar system or if it's a long ways away, you might not even hear that generator. The line could still be energized. Or it could just have to under look safely. The system that we have built here, we have the transformer that we're backfeeding. We have overhead line to represent a normal power line. At the other end of this, we have a little person. And the person, where his hand would be, is a hot dog. Hot dogs are made of the same material that people are, right? A lot of moisture and some meat. Connected on the back side of the hot dog is a wire that runs to the top of the little victim's heart that we have there. We're using a grapefruit to represent the victim's heart. And on the back side of the heart, of course, the wire comes down to the bottom wire over here. So that represents a complete path for current to flow. We're going to demonstrate what happens if a person makes contact with the line, and we'll burn the hot dog up, we'll burn the grapefruit up. Are you ready for power?
you just want to touch phase.
Power's coming on. So we can see that it's energized because the light's on, but you don't hear anything. Now, you probably can't quite hear that, but he's getting a little bit of a fuzz. Kind of like when we did the small tabletop demonstration, you can see that little RP. We're getting a little one of those. But it's almost like a bird landing on the wire. A bird doesn't represent a short circuit. There's no current path. So when the bird lands on the wire like that pipe, it doesn't short anything out. All right. Now, if you touch the bottom wire at the same time and then touch the top, definitely a lot of energy there. All right. So let's go ahead and see what happens if you were holding something. Let's touch it to the hot dog first. If you were touching something on a hot in your hand, so we've got a pipe in his hand, and he makes contact with the wire. You can keep doing it. Hold it there for a while. You can see the damage to where the hand would be, but that grapefruit is only connected because it's flowing through that body. So the grapefruit is where the heart is. Certainly that would not be a good thing for a person's body to have happen to it. So you never want to make contact with a power line. What we would really like is that everybody stays over 10 feet away from any of our power lines for certain. Now to me, let's go 20 feet. Because sometimes sitting in a large sprayer, it's hard to know what 10 feet is. So let's go 20 feet away from that. Don't get any closer than that. Stay away from power lines at that point. We'll go ahead and do another demonstration with that. Let's do that one more time. Common problem for us is to have a tree branch fall across the line and cause an outage, or often tree branches are just close to our line and can cause problems. When a tree branch makes contact with our line, it can certainly cause the power to go out, but it could also create some fire hazards with this as well. It could cause the wire to come down and create an arc on the ground, and California has experienced some serious wildland fires because of that. We've experienced grass fires because power lines coming down as well due to damage. So what we're going to do is we're going to demonstrate what happens when a tree branch is in the line. And often the tree branch doesn't short out immediately. It has to track through it. So we'll take a little bit of time to demonstrate this. Power coming on. Now it didn't short out immediately, but you can see smoke coming from the tree branch. As the electricity is tracking through the internal parts of that branch, following the moisture in the sap, it's boiling inside there. And that boiling is what we're seeing the expansion of the gases coming out of it. It'll get faster and faster. You'll see electrical tracking from the top to the bottom. It'll take a little while, but eventually it'll short circuit. This is one of the reasons it's so important to let the tree crews come in and do their work and clear the lines of tree branches. We want to make sure that we keep the lines back. We don't want trees that fall into the line as well. We come knocking on your door about every 3 years to cut the branches. If we could convince you to plant some trees further away from the line and let us take those trees down, we wouldn't have to go to the expense of maintaining those trees in the future. You can see it's tracking pretty good now. It's starting to arc a little bit more. Now our power lines are designed to keep the power on, not just shut it off. In your home, a breaker should trip if something was short-circuiting or arcing like this. Everybody's experienced their lights blinking before. You know, your lights blink during a storm. If we had breakers like you have in your house, they wouldn't blink. They would just go out the first time. Our mission is to try and keep your lights on, so we try to blow things clear. If this were to arc pretty good, hopefully we could just get it to burn and fall off the line so your lights would stay on. Sometimes it doesn't. It trips the breaker. The breakers are designed often to work about 4 times. Blink about 4 times, hit the line again 4 times before the power goes out. After 4 times, it goes to a lockout situation, and we'll have to send a crew out to see if they can clear the problem. Starting to get a little bit hotter, starting to track. You can see sparks going up into the branch a little bit further now as well. We've got good contact with the main part, so it's not going to just burn itself clear. It's tracking from the top to the bottom. And you can see the sparks. Once those sparks make contact with each other, it completes a path to ground, and it short circuits. So we're getting a little closer as we go. There we go. So at that point, a breaker would trip, the breaker would come back on. If the fault was still there, it goes back off, it comes back on, the fault's still there, it goes back off. It's going to do that 4 times, and then eventually lock out, and a crew has to go and take this off to clear the problem. Hopefully the wire doesn't burn down in the meantime, so we have to put the wire back up and things like that as well. All right. Now once it's tracked through, it doesn't take much for it to happen again. So there was a little bit of wind. There you go. So a crew would have to now go out and clear that problem and fix it so we can put the lights back on. I think we got another demo, if we want to pop that one off quick. And let's throw that fire hose over it. There we go. So this is just a standard piece of 1 3/4 fire hose that a fire department would use. It doesn't have any water in it. All we did is we did wet the jacket a little bit as it would be on the fire ground. And this is another one of those things that kind of surprises people. Doesn't look like anything's happening, but I don't know if you can hear it or not, but it's arcing. You can see it arcing at the bottom. When it's arcing at the bottom, it has to be traveling through the entire hose. So that is clearly conducting electricity right there.
So if that hose was filled with water, somehow
yeah, it's going to completely conduct. Yeah, all the way to the ground.